Hello guys, welcome to another video here under the Web Fundamentals series, and we're treating the introduction to web hacking module, and today we're going to be treating authentication bypass. Here we're going to learn how to defeat logins and other authentication mechanisms to allow us access to unpermitted areas. Okay, task 1, brief. I'll just quickly start this machine because that's what we need. Now in this room we will learn about different ways website authentication methods can be bypassed, defeated, or broken. Now, these vulnerabilities can be some of the most critical, as it often ends in leaks of customers' personal data. Now, start the machine and then proceed to the next task. We've done that. I have started the machine, so completed. Task 1, done. Task 2, username enumeration. Now, a helpful exercise to complete when trying to find authentication vulnerabilities is creating a list of valid usernames, which we will use later in other tasks. Now, website error messages are great resources for collating this information to build our list of valid usernames. Now, we have a form to create a new user account. If we go to the ACME IT support website, which just got ready, so I'm just going to right click and open into a new tab. The support website sign up page would enable us to create a new user account. Now let's just go on. I'm going to create that soon. Now if you try entering the username admin and fill in other form fields with fake information, you will see we'll get an error message that says an account with this username already exists. Now we can use the existence of this error message to produce a list of valid usernames already signed up on the system by using the FFUF2, the fuzzing tool. Now the FFUF2 uses a list of commonly used usernames to check against for any matches. Okay, now I'm just going to go here. Let's quickly try that. I'm going to zoom in a little bit. Now the username we can use is admin. If I type in admin here, okay, and I'm just going to put in any maybe admin@admin.com, just something simple. Password, I'm just going to type AAA111122 and AAA111222. Okay, something like that. Sign up and don't save. Watch what it says. An account with this username already exists. Okay, now in the above example, the -w argument selects the file's location on the computer that contains the lists of usernames that we are going to check exists. Now the -x argument, we just completed -w. Now the -x argument specifies the request method. This will be a GET request by default, but it is a POST request in our example because we're submitting a form. Okay, now the -d argument specifies the data that we are going to send in our example, Now in our example we have the fields username, email, password, and password. Okay, now most especially what we're going to be forcing is actually the username. So you see, and email equals to X, password equals to X, and password equals to X. Okay, now we have set the value of the username to false because that's what we're forcing, right? Now in the FFUF2, the false keyword signifies where the contents from our word list will be inserted in the request. Now the -h, which is this argument, is used for adding additional headers to the request. In this instance, we are setting the content type, so the web server knows we are sending the form data. Okay, and the -u argument specifies the URL we are making the request to. And finally, the -mr argument is the text on the page we're looking for to validate we have found a valid username, which is username already exists. Okay, the FFUF tool and word list come pre-installed on the attack box. I'm not using the attack box here, or can be installed locally by downloading it from this GitHub link. Now create a file called valid_username.txt and add the usernames that you found using the FFUF. This will be used in task 3. Answer the questions below. Okay, I'm just going to go into my my terminal here, but I will just copy this since we just explained it. I'll just copy it directly and just make some modification. Okay, just copy and Ctrl+Shift+V. So I have this here. What am I going to change? The location of this the word list here, which is the name names.txt, is saved in a separate folder. I'm going to try to close this all. I say just delete them all, and word list is correct. So I'm looking at under the word list here, you can see I have a sec list here. Enter. Under my sec list, I have usernames here. Enter. Under usernames, I have names, and under names, I have names.txt. Okay, so you see now I think we're ready. Now there are two ways I can save the names that or the result. I can either pipe the result of this code, or I can just directly save it once I get the form. So let's just do the later. So it's going to take time. So what will happen is I'm going to come here and I'm going to create the file list nano valid underscore username dot txt. I'm going to hit enter. So the first result I have here is admin. I'm going to be waiting for the other results. Once it's complete, I'll just add them here and save the file so that we can use them later. Okay, so we have we have a result. It's finished. So we have admin, Robert, Simon, and Steve. That's the result of the usernames that we got from the forcing. So I'm just going to type Robert. Enter. The next one is Simon, and the next one here is Steve. So Ctrl O to save it to valid underscore username.txt. Ctrl X to finish, or to go out of the nano 2 here. So I've saved that, and if I list here, I'm going to see I have valid username.txt. If I do it here too, I think I see it there. Okay, great. So now let's answer the questions for task 2. What is the username starting with S? That should be Simon. Simon. And what is the username starting with ST? That should be Steve. Okay. And what is the username starting with RO? That should be Robert. And these are the names we got from the forcing 2. You can just cut valid.txt. That's the names you can see. Okay. That being said, now let's go on to task 3. Task 3 is brute force. So use the valid username.txt file we generated in the previous task. We can now use this to attempt a brute force attack on the login page, which is the login page here. You can just open it. Note, if you created your valid underscore username file by piping the output from FFUF directly, you may have difficulty with this task. Clean your data or copy just the names into a new file. So I believe I knew it was going to be having just both the names, and let me show you what it means. This is how it would have saved it if I have piped it alongside with the status code, size, and all that. So I think it was better for me the way I used nano to do it, but that's a different option. You could save it and then just edit it by cleaning, but I think this is faster. Okay, now a brute force attack is an automated process that tries a list of commonly used passwords against either a single username or, like in our case, a list of usernames. Now when running this command, make sure the terminal is in the same directory as the valid username.txt file. Okay, this is the code. Let's see what it means, what we're using here. The FFUF command is a little different to the previous one in task 2. Okay, now previously we used the force keyword to select where in the request the data from the word list would be inserted, but because we are using multiple word lists, we have to specify our own force keyword, and in this instance we have chosen W1, which is the one we saved. so we want that one as the word list 1, and we also want to the FFUF to force the list of password as well, so we're going to use that as word number 2. Okay, that's okay. Now in this instance, we've chosen W1 for our list of valid usernames and W2 for the list of password that we will try. In this case, we're going to be using the sec list passwords. The multiple word lists are again specified with the -w argument, or separated by a comma. So we have this valid underscore username.txt, which we call W1, comma, then the word list link for the passwords, which is W2. Okay, so it was separated with a comma. And then for a positive match, we're going to be using the -fc argument to check for HTTP status codes other than 200. Okay, so any other HTTP status code other than 200, right? Okay, now running the above command will find a single working username and password combination that answers the question below. All right, again, it's quite a long command. I will just copy it, and let's head on here. I'm using here Control L, clear. Okay, for some reason I had to type this out because the password list that I have is quite different, more like the location of my passwords, the common passwords here. So let's see if this works. Okay, it's running. Let's see. Okay, finally I've got the result. It took me quite a while because I just copied and pasted, did some adjustment, but it still didn't work for some reason, so I had to type it out by myself. So after typing it out, just the same thing, just the difference is the location where I have my password list is different. Now, so we have a result here: W1 Steve for username, W2 Thunder for what's it called, for the password. Okay, so this is, let me show you the example of the piping I was talking about, maybe like saving the result into something. So I'm just going to use this forward icon here. I want to save it as result.txt, and I'll hit enter. It will do the same thing, but at the end of it, I'm going to have a new file called results.txt. So if I ls now, I should be able to see a result.txt here, and if I cut that result.txt, cut result.txt, you're going to see W1 this, W2 this. So the difference now, why I said we just put the name, created a nano separately, because you would see this star W1 inside the file, star W2 inside the file as well. Okay, so let's go continue and answer the questions here. What is the valid username and password? Format is username / password. So we have let's see what we have as a result. Again, we have Steve and Thunder. So we have Steve and Thunder. Enter. Okay, sorry, not colon but /. Correct. So now we're done with task 3. Let's head into task 4. Logic flaw. What is a logic flaw? Sometimes authentication processes contain logic flaws. A logic flaw is when the typical logic part of an application is either bypassed, circumvented, or manipulated by a hacker. Now, logic flaws can exist in any areas of a website, but we are going to concentrate on examples relating to authentication in this instance. So basically, from the picture what you see here, a hacker will just move directly from step 1 to step 4, while the intended part is supposed to have step 1 verified, step 2 verified, step 3, then step 4. Now let's see this. Now the logic flow example. The below mock code example checks to see whether the start of the part the client is visiting begins with a /admin. Caps is noted or small letter, and if so, then further checks are made to see whether the client is in fact an admin. If the page doesn't begin with a /admin, the page is shown to the client. The page is shown to the client if it doesn't start with admin. So that's moving from step 1 to step 4. So now this is how the code looks like. If URL substring 0,6 is not, you see they use 3 =2, so it has to be exactly the way it is. Okay, Now, because the above PHP code example uses 3 equal signs, 1, 2, 3, it's looking for an exact match on the string, including the same letter casing. Okay, so the casing here is important. Now the code presents a logic flaw because an unauthenticated user requesting /AD capital letter M, well, still admin, but the casing here is changed, will not have their privileges checked and have the page displayed to them, totally bypassing the authentication checks. Now let's look at logic flaw practical. Now we are going to examine the reset password function of the ACME IT support website, which is HTTP, which is this. So I'm going to open this and I'm going to close this and close this. So this is where we are, right? Okay. We see a form asking for the email address associated with the account on which we wish to perform the password reset. Now, if an invalid email is entered, you receive the error message, account not found from supplied email. Now, for demonstration purposes, we'll use the email address robot@acme-it-support.thm, which is accepted. We are then presented with the next stage of the form, which asks for the username associated with these login emails. If we enter robot as the username and press the check username button, you will be presented with a confirmation message that a password reset email will be sent to robot@acme-support.thm. Okay, now let's try this. So we're going to use, this is the account request name. Let me see. If I use a hacker, just okay, I think I have one here. Hacker check email, and it says account not found from supplied email. But if we use the same email provided for us here, the robot@acme-it-support.thm email, Ctrl C here, let's Ctrl V here, enter, check this email. If we do check this email now, we'll see the next stage is to write the username. The next stage is to write the username, which is robot. Okay, username robot as the username, right? So we're going to use robot and then check the username. And once you do that, you see we'll send you a reset email to this. So this is what it does when it recognizes an email, right? Now at this stage you may be wondering what the vulnerability could be in this application, as you have to know both the email and username, and then the password link is sent to the email address of the account owner. This walkthrough will require running both of the below call request on the attack box, which can be opened by using the blue button above. So I'm not using the attack box, I'll use my machine here, my terminal. Okay, now in the second step of the reset email process, the username is submitted in a post field to the web server, and the email address is sent in the query string in the request as a get field. Okay, now let's illustrate this by using the call tool to manually make the request to the web server. I'm going to copy this directly, but let's see what the code does. Now we use the -h flag to add additional headers. Of course, -h for headers. In this instance, we're going to be using the content type to application /x-www.form.-url encoded. Now, which lets the web server know we are sending form data, so it properly understands our request. Okay, that's the -h argument, right? Now in the application, the username is retrieved using the query string, but later on in the application logic, the password reset email is sent using the data found in the PHP variable, which is this $request. Now the PHP request variable is an array that contains data received from the query string and post data. Now, if the same key name is used for both the query string and post data, the application logic for their variable favors post data fields rather than the query string. So if we add another parameter to the post form, we can control where the password reset email gets delivered to. So if we copy this call here, you see this particular HTTP is the reset link, then the header, and then username robot. So let's call that now and see. I'll use here Ctrl L. So let me clear this too, so it won't be confusing. Ctrl Shift V. So I'm going to just call that right now, and we got the request. So Now for the next step, you will need to create an account on the ACME IT support customer section. Doing so gives you a unique email address that can be used to create support tickets. Now, the email address is in the format of username, which you're creating at customer.acmeitsupport.thm. So I'm going to create an account, and to quickly create an account, I think just come here, create customers. Customers, I'm going to create sign up here. I'm going to use a username hacker. Let me just make it simple, hacker. And then I'm going to use email address as hacker THME. This should be like the email address I'm going to use, hacker at acmeitsupport.thm. Okay. Password, I'm just going to use A112233. A112233. Oh, what? A112233 and A112233. Let me see something like that. Submit, and I've created this account. Okay. Now, the username I use is hacker, so we'll note that. Now, we're going to rerun the call request too, but with your at ACME at support.thm, which is hacker. Made that easy already. And in the email feed, now you have a ticket created on your account which contains a link to log in as robot. Using robot's account, you can now view the support tickets and reveal a flag. So I'm just going to copy this call request here. Let me see. Ctrl C. I'm going to change something here. Ctrl L, Ctrl Shift V, and this time I'm changing the username here. I'm going to just put hacker equals to hacker. I will hit that, and we've manually sent that request. I'm going to go back to my page here, refresh, and I should get an email here. Yes, so we have one support ticket. Click on support ticket. We have password request ticket. I'm going to click on the ID here, and here it takes me to the message. Okay, now we've received a request to reset your password. Please visit. I'm just going to copy that link all the way to this point. Ctrl C to automatically log in, and then you can reset your password from there. So I'm just going to open a new page here, Ctrl Shift V, and hit enter, and there we go. So we resetted this account, but it's the account now is basically, if you look here, you see it's robot account. Okay, all right, now I'm going to click on support ticket, and I'm going to hit a ticket here, one, which is under here. So please don't tell anyone. This is our flag. Ctrl C, and I'm just going to paste it here, enter. Okay, that solves task 4 for us. And last task here, which is task 5, cookie tampering. Okay, examining and editing the cookies set by the web server during your online session can have multiple outcomes, such as unauthenticated access to another user's account, or elevated privileges. If you need a refresher on cookies, check out the HTTP in detail room on task 6. Okay, plain text. Now, the contents of some cookies can be in plain text. Okay, plain text, and it is obvious what they can do. Take for example, if this were the cookie set after a successful login, set cookie logged in as this, set cookie admin equals to false. Now we see that one cookie is logged in, which appears to control whether the user is currently logged in or not, which is set to true. And another is admin, which controls whether the visitor has admin privileges. Using this logic, if we were to change the contents of the cookie and make the request, we'll be able to change the privileges. So first we'll start just by requesting the target page. So if we try this target page, it's going to tell us that we are not logged in. Ctrl C, let me try that. Alright, Ctrl L here, Shift V, call that, and not logged in. So we're not logged in. So we can see we are returned a message of not logged in. Now we will send another request with the logged in cookie set to true and the admin cookie set to false. Okay, so we'll try this code, Ctrl C, and we're going to Ctrl+V that and enter. It will tell us logged in as a user. Okay, so we're logged in as a user. So if I come back here now, we're giving the message logged in as a user. Finally, we'll set one last request, setting both the logged in and admin cookie to true. Okay, so I'm just going to go back here. This time I'm going to edit that code as simple as putting the admin here to be set to true, and hit enter, and we get logged in as admin, and we have our flag right there copied. Okay, so this returns the result logged in as an admin, as well as a flag which you can use to answer the question 1. Next is hashing, so I'm just going to paste that here for question number 1 answered. So let's go hashing. Sometimes cookie values can look like a long string of random characters. Now these are called hashes, which are irreversible representation of the original text. Here are some examples that you may come across. So we have original string here was 1, but for the hash method MD5, we see the length of the hash string here. Now you can see from the above table that the hash output from the same input string can significantly differ depending on the hash method in use, even though the hash is irreversible. Now the same output is produced every time, which is helpful for us as services such as the crack station. We're going to use that, so I'm going to open that. Keeps database of billions of hashes and their original strings. Now encoding is similar to hashing in that it creates what would seem to be a random string of text, but in fact the encoding is reversible. And so it begs the question, what is the point in encoding? Encoding allows us to convert binary data into human readable data or human readable text that can be easily and safely transmitted over mediums that only support plain text as key characters. Now, common encoding types are base 32, which converts binary data to the characters A to Z, caps, and 2 to 7, and base 64, which converts using the characters lowercase a to z, uppercase a to z, 0 to 9, plus / and the equal sign for padding. Now take the below data as an example, which is set by the web server upon logging in. Set cookie session equals to this, and this string base 64 decoded has the value id equals to 1, admin equals to false. So we can then encode this back to base 64, encoded again, but instead setting the admin value to true, which now gives us admin access. So this is basically how we can use it. So let's answer some question. What is the value of the MD5 hash for this string here? The string of length, we're probably going to be using the crack station website here. Okay, so I'm going to paste that and crack this hash, and here we have the hash is this, the type is MD5, the result is this. I'm going to copy that result, and that should be the answer to our second question here. Submitted. Let's see the hint. The hint crackstation.net can help us. That's what we used. Now, what is the base 64 decoded value? We're going to use base 64 website. I think that's 64. That's base 64. Yes, to encode. This is the website, base64decode.org. This is what we're going to be using. So this is the value of the base 64, and we want to decode it. Once we do that, it should give us the answer here. Tryhackme flag base 64 encoding. I'm going to come back here and paste this. Submit. Great. Encode the following value using base 64, and that should start with id equals to 1 and admin equals true. Copy, Ctrl+C there. I'm going to come back to this part here. You see the code here. We're going to use encode. I'm going to paste this and going to encode here. Scroll down, you see we can copy this. This is the encoded base 64 of what we had here, and submit. That's our answer. And that brings us to the end of this room, Authentication Bypass. I love the room. Thank you for studying with me. Thank you for learning with me. I'll see you guys in the next room, which is the idle vulnerability room. And enjoy the rest of your day. Ciao.